परीक्षा में मुझे भी बारह पर 12:30 डाल के दीजिए कितना 15 हो जाए ठीक है सेटल जाते हैं। Okay, whether the slide is visible? Anyone, please respond. Hello.
Yes, sir.
Okay. So, okay, good morning to all of you. Today we will continue from where we have discussed in the last class. So, let me just quickly overview this. So, we have discussed the technique for prioritizing the system test cases based on the requirements which are proposed by Srikanth ETL. That work we have discussed in the last class, and that technique was known as four prioritization of requirement for test. They have considered four factors that also I have already told you. Those four factors are customer assigned priority of requirements, requirement volatility, developer perceived implementation complexity, and the faultiness of requirements. This we have discussed. Based on that, some weights we are giving, maybe on the range of 1 to 10, and they are calculating a factor called as prioritization factor value using this formula that also we have discussed in the last class, and we have taken an example, isn't it? So those things we have seen in yesterday last class. So we'll take an extension of this approach proposed by Srikanth ETL. So another extension is there. So here they have taken four factors, four parameters. So another research is there, another work. They have extended this work and added three more parameters. This approach for prioritization of regression test cases was proposed by Kavita and Kumar. So they have taken 7 parameters. I think the first 4 are almost similar to the previous one, like customer assigned priority of requirements, changes in requirement. In that case, we are saying requirements volatility. Requirements volatility means how far, how frequently the requirements are changing. Number 3 was also there, developer perceived code implementation complexity. Number 4 was their fault proneness, and here the parameter is just fault impact of requirements, almost similar. And 3 parameters they have added, like what is the completeness of the requirements, whether the requirements are complete or incomplete. What is traceability? Traceability we have already discussed, whether you can easily trace from the coding to design to requirements, etc. That traceability. And then the execution time, how much time it takes to execute your test case. So you can assign similarly some weights to these what factors, and then similar what equation can be developed, and then you can prioritize the test cases. So this is an extension of the previous approach. Based on these factors, a weightage is assigned to each test case, and the test cases are prioritized according to the weightages. Now we will see another important approach. It's another important approach for test case prioritization based on the requirements. That means from the requirements, we do not want the design or the code to prioritize test cases. Directly, if the SRS document is ready, we can design the test cases and we can prioritize them. So this approach for test case prioritization is based on requirements. This was proposed by Kumar and Chauhan. This Naresh Chauhan, who is the author of this book. So this work was proposed by Kumar and Chauhan. So they have proposed a hierarchical test case prioritization approach, where prioritization is performed at 3 levels. That means if prioritization is performed, it has 3 steps. In the first step, they first prioritize the requirements on the basis of 12 factors. They have identified 12 factors. I'll show what are the 12 factors. Based on these 12 factors, they have prioritized the requirements by assigning a weightage value to each requirement. Then they are prioritizing modules. How? They are mapping the requirements to their corresponding modules in order to get the prioritized modules. And finally, last step is ranking the test cases or prioritizing test cases of the prioritized modules for execution. That means first they are prioritizing the modules, then each module might have some test cases, then the prioritize the test cases of these prioritized modules. Okay. Let's see the first step. First step is prioritization of requirements. The process of prioritization of the requirements is performed on the basis of 12 factors. These factors are in accordance with the phases of the SDLC, like requirement specification, design, coding, testing, etc. I'll show these 12 factors. All these factors, then they are assigned a priority value in the scale of 0 to 10. So 0 may be the lowest priority, 10 might be the highest priority. These priority values are assigned by various stakeholders of the project. So next I will show what are the 12 factors. These are the 12 factors. One is requirement volatility, how frequently the requirements are changing. Then customer assigned priority, how much priority is assigned by the customer for this particular requirement, whether it is low priority or high priority. Like if it is this security, they may give a very high priority value, UI may give a low priority value. Then what is the implementation complexity? You can see that requirement volatility, it comes under the requirement analysis phase, and here the priority value will be assigned by the customer. So the customer assigned priority, again it comes under the requirement analysis phase, and it will be what the priority will be by the customer. Then well, the fault provenance we have already seen in the first one. Again, it comes in the design phase and it is given by this developer. The priority is given by developer. The developer assigned the priority. How much priority is assigned by the developer? So again, maybe in the requirement analysis phase, given by developer. So the stopper requirements, that means when the requirements will be frozen. So stopper requirements, again, it is performed at the design phase and the priority is given by developer. Frequency of execution of requirements, which requirement is executed how many times? Again, the requirement analysis and priority given by developer. Similarly, they have identified the factors in which phase they are coming and who assigns the priority value. Next priority is expected falls, then what is the cost of those requirements, what is the time, what is the penalty if you will not fulfill the requirements, then traceability. So these are the different 12 factors, and which factor is coming under which phase, and then who assigns the priority value. So based on these 12 factors, let's see how they assign the weighting. For each requirement, based on these 12 factors, a requirement prioritization factor value, RPFV, requirement prioritization factor value is calculated. How? By using the following equation. So this is equal to RPFV equal to summation of j equal to 1 to n, PF value into PF weight. So PF value ij into PF weight j. So let's see what is I represent here. I represents the number of requirements, j represents the number of factors. PF means what this prioritization factor value, and this is the exactly what is the value, and PF weight means what weight you are assigning. Prioritization factor weight, what weight you are assigning. Similar things already you have seen in the last class. What does this RPFV represent? RPFV represents the prioritization factor value for a requirement, which is the summation of the product of the priority value of the factor and the project factor weight. So now let's see the equation. What does PF value represent and what does PF weight represent? So in this equation, PF value represents, it is the value of the factor for the ith requirement, whereas PF weight is the factor weight for the j factor for a particular project. Then by using the previous equation, the weight prioritization factor of called as RPFV for every requirement is calculated. And now let's see how the RPFV values are calculated for each requirement. So I have already told you there are 12 factors. Suppose I am having 4 requirements. This is a simple example. Suppose in my project there are 4 requirements. So I have already told you for these factors who will assign the what priority. So by requirement volatility, it will be assigned by the customer, or the implementation complexity will be assigned by the developer, and things like that. So these are the 12 factors. These are these 4 requirements. So from their experience or for understanding the problem, the different persons such as customer, developer, analyst, they assign the what weights to these what factors, like customer assign priority. Who is assigning? The customer. So customer, according to his experience, he is assigning weight 8 to R1, weight 10 to R2, weight 9 to requirement R3, and weight 9 to requirement R4. Okay. So, and you know that total number of weight is 1. Just in LU case, total weight is 1. You have to divide them, and you divide in such a way that when you add up all the weight factors, the total value should be 1. And suppose from his experience he is giving weight is 0.02. Similarly, the developer assigned priority, developer is assigning a factor or a value of 8 to R1, 9 to R2, 9 to R3, 8 to R4, and the weight factor is calculating 0.08. Like that, every factor will be assigned some values and the weight factors by the concerned persons, such as customer, developer, or analyst. This is a typical sample is an example where the different stakeholders they are assigning the values. Then you can find out RPFP how by using this formula. P value into PFP, and so RPA value for this it is added using this. Okay, and similarly RPA for R2 and this it is being calculated using this formula. You can see if PM values are given, weight is also given, values are given, weight are given. Use that formula, you will get these values. So finally, you have got RPFB for requirement 1 is 2.25, RPFB for requirement 2 is 4.77, RPFB for R3 is 4.15, and RPFB for R4 is 2.47. The weights you have to give in such a way that when you add up the weights, this must be 1. So now you can easily prioritize the requirements, because what is the first step? First step is requirement prioritization, factor value. We have to prioritize the requirements. What is the first step? First step is prioritization of requirements. So now we see those 4 requirements can be prioritized as follows. First priority will be given to which one? R2, because the highest RPFP value 4.77. Next priority is R3. Next priority is R4. Last priority will be given to 2.25. These are 1. So in this way, prioritize the requirements. Okay. So that's why this is the prioritization order of the requirements is R2, R3, R4, and R1. Okay. So so you can see from this previous table that the RPFP value depends on what? The values of the PF value and PF. Okay. Now we'll go to the second phase. What is the second step? Second step is prioritization of the different modules. How you can do it? What is the objective of this prioritization, or what do you mean by prioritization of the modules? In your software, there will be several modules. So the prioritization of modules, it is a process of mapping between what? It is a process of mapping between the prioritized requirements and their corresponding modules. So which requirement corresponds to which module? So this prioritization of modules is a process of mapping. Mapping what? Mapping the prioritized requirements with their corresponding modules. If there is more than one module, then only the modules are prioritized. If just one module, no need to do the prioritization. So this prioritization of module, it uses 2 important components. One is the cyclomatic complexity, another is the non-DC path. We have already discussed the cyclomatic complexity earlier while discussing white box testing. We have told that cyclomatic complexity V is equal to E minus N plus 2, where E is the number of edges and N is the number of nodes. And the non-DC path also we have discussed while performing this integration test. So for your easy reference, I am again repeating what you mean by the DC path, so that you can understand what is non-DC path. DC path stands for definition of clear path. We have already seen earlier. A DC path with respect to variable V is a path between what? Between the definition node and the usage node, such that no other node in the path is a defining node of variable V. That means once you have defined that statement 1 variable V, you are using that statement 10 variable V. In between statement 1 to 10, nowhere variable V can be redefined again. Then that path from S1 to S10 we call as DC path. Alright, if you are redefining in between, that is called as a non-DC path. And you know that these DC paths are very easy. There are less errors. There are less errors. Why? Because you are defining only once and you are using at the end only once. No redefinition in between. But if you try to redefine many times in between, obviously there will be more fault prone. So that's why we are saying DC paths are less error prone, whereas non-DC paths are more error prone. The test cases of higher priority modules are prioritized first and executed. So now what you are doing, you are prioritizing the modules using cyclomatic complexity and non-DC path. Then what you do, the test cases of the high priority modules are prioritized first and executed. So after prioritizing the modules M1, M2, M3, M4, which module is of high priority? What you do after prioritizing modules? You see the corresponding test cases, the corresponding test cases. The test cases of the high priority modules, they are first prioritized and executed. Now let's see how you can prioritize the modules. For each module, a module prioritized value is calculated, just as RPFV. For each requirement, we are calculating RPFV in the previous slides. Similarly, for each module, we have to calculate a value called as priority module priority value. How you can calculate it? This can be calculated using two components. One is the cyclomatic complexity of that module, which you can obtain by V is equal to V minus n plus 2, and then by finding out how many non-DC paths are there in that module. You sum up, you add these two values, cyclomatic complexity and number of non-DC paths, then you will get this module prioritized value. Then you sort them according to the descending order, the MP, MB, MP, V values are sorted, then you can prioritize them. We'll take a small example. Suppose in your software project, there are 4 modules, M1, M2, M3, M4. And suppose M1 is having cyclomatic complexity 8, M2 is 4, M3 is 4, M4 is 5. In M1 there are 7 non-DC paths, M2 5, M3 is having 6 non-DC paths, M4 is having 3 non-DC paths. Then MP value is just addition of cyclomaticity and non-DC paths. So for M1 MP is 15, for M2 is 9, for M3 is 10, for M4 is equal to 8. So how to prioritize? You can see that the highest MP value is in M1, so M1 will get the highest priority. Then module M3, then module M2, then module M4. In this way, prioritize the modules using the corresponding MP value. This I have already told you. This is the order of the modules M1, M3, M2, M4. Isn't it? First is M1, then M3, then M2, then M4. Okay. In this way, prioritize the modules. Then we will come to the last step. So after prioritizing the modules, what we have to do? We have to prioritize the corresponding test cases. So if there is one module, no need to prioritize. If there are multiple number of modules, we have to see each module is associated with some test cases. We have to first execute. We have to the test cases of the highest priority module. So already we have prioritized the modules. Then we will see in each module there can be several. Each module may be associated with several test cases. So now, how to prioritize the test cases for a given module? This is called a test case prioritization process. Let's see how we can do it. So the last step is test case prioritization process. This step is used to prioritize and schedule the test cases corresponding to what? Corresponding to the prioritized modules. So here again some weight factors are used for this test case prioritization process, such as, so this method uses 4 factors, such as test case complexity. What is the complexity to design the test case? Requirements coverage. Your test case covers how many or executes how many requirements. Dependency of the test cases, whether the test cases are independent or some test case is dependent on some other one. Like first T1 has to be completed, then only T3 can be executed. Then we say that test case T3 is dependent on the test case T1, and then test impact. What is the impact of your test case? So like this, 4 factors are taken, and you can assign some weights to these factors. So now let's see. First parameter is test case complexity. What do you mean by test case complexity? Test case complexity shows how difficult it is to execute a test case. It also shows how much effort is required to execute the test case. This factor you can assign a weight, a value in between 1 and 10. So this is about the first parameter, test case complexity. Next one is the requirements coverage. What do you mean by requirements coverage? Requirement coverage simply shows how many requirements are covered by executing the test case. When you are executing test case, suppose T1, you are having 4 requirements. How many requirements it cover or execute? Whether all 4 or only 3 or only 2 or only 1 or 1. So accordingly you assign some weight. This factor is also scaled between 1 to 10. You can give the weight between 1 to 10. So what is the higher value? Suppose you have given 10. What does it represent? A higher value shows maximum requirements are covered by the test case. If your test case T1 covers all the four requirements, then you give 10. If it covers 2 requirements only, R1 and R2, you may give 5. So obviously, higher value shows maximum requirements are covered by the test case. Higher the number of requirements coverage, higher is the priority of the test case to be executed fast, isn't it? So if your test case covers many requirements, then it is more priority because it's covering all the requirements. You must give high priority to this test case. Very simple. If it is covering only one, I can give as a least priority because if you will execute only one requirement will be covered or executed. So you can give least priority. So higher the number of requirements coverage, higher is the priority of the test case to be executed fast. But in by dependency, it shows the dependency of test cases on some prerequisites. Isn't it? So dependency means it shows the dependency of the test cases on some prerequisite or on another test case. It shows how many prerequisites are required for each test case before execution of the particular test case. So before executing test case T3, how many prerequisites are there? That prerequisite can also be under test case. Like before executing T3, suppose T1 has to be executed. This is a dependency. This is a prerequisite. So in this way, you have to find out how many prerequisites are required for each test case before execution of the test case. Again, here you can assign a value in between the range 1 to 10. The last parameter is test impact. It is the most critical factor in the test case prioritization. And what does it show? Test impact. It shows the impact of the test case on a system. It is not executed. So if you will not execute the particular test case T, how does it impact on the system? What things you are going to miss? That means certain parameters, certain what aspects they cannot be tested. How far severe they are? What is the impact on the released product? So it shows that the impact of the test case on a system if it is not executed. This factor assesses importance of the test case. As its name suggests, so this test impact, this factor assesses the importance of the test case. Again, here you can assign a value in between 1 to 10. Any value, any weight in between 1 to 10, you can assign to this factor, to this parameter test impact. Now let's quickly see how you can assign the weight. Here, for priority test cases, you calculate another factor called as TCWP, which stands for test case weight prioritization. This we can calculate as using a small equation like f value ij into f weight j, and take the summation from j is equal to 1 to n, where TCW stands for the weight prioritization for each test case. For every test case, find out this value or this weight prioritization TCWP. So TCWP is the weight prioritization for each test case, which is calculated from the 4 factors. What is F value? F value, this is the value assigned to each test. So here F value can see F value ij. F value means the value assigned to each test case. F weight means the weight assigned to each factor. How much weight you are assigning to each factor, that can be represented by F. In this way, you find out this TCWP value, that is the weight the test case weight prioritization or weight prioritization for each test case using this equation. Okay. So after calculating the values, of each test case, then test cases are ordered how? By using the values of TCWP, such that maximum TCWP value it will give a test case. The maximum TCWP value gives a test case the highest priority, and it will be executed first. If it is having lowest TCWP value, then it will be given the least priority and it will be executed at the last. Suppose your test suite contains a set of 4 test cases, TC1, TC2, TC3 and TC4, and they have to be prioritized. You have to prioritize them. So suppose module M3 contains 4 test cases, TC1, TC2, TC3 and TC4. You need to prioritize them. Then how can you do? Again, we will follow these steps that I have told. Find out the F value, F weight, then come to TCWP value, then sort the test cases according to the decreasing order of the TCWP value. Okay. For these test cases, TCWP is calculated by using the above equation, and they are prioritized on the basis of what? On the basis of TCWP. Okay. So for these test cases, TC1, TC2, TC3, and TC4, the TCW is calculated by using this the above equation, and they are prioritized on the basis of the values of the TCW. Now let's take this example. As I have already told you, I have taken 4 test cases for this module M3, TC1, TC2, TC3, TC4. 4 factors are there, and the tester is assigned these values to these the test cases from his experience. These weights are given like test impact. It's having test impact is the most important. It is given highest weight 0.4. Next weight is to test case complexity 0.3. Requirement coverage is next weight is 0.2, and dependency is the least weight, that is 0.1. So that see, any assignment mechanism you take, so that the total weight must not exceed 1. This should be 1. Accordingly, what decompose this 1 into different weights. Then these are the values are given. These are the weights. Then TCW can calculate using this formula. Okay. So they have calculated the TCWP for each test case. Looking at this table, you can see that TC4 is the highest. It must be given highest priority because this is very much important. Its value is TCWP highest at 7.90. Next is 6.30. This is the TCWP value of TC2. So TC2 will be given second priority. Then third priority will be given to TC1 because its TCWP value is 5.90, and the last priority will be given to what TC3 because its TCWP value is 5.0, which is the least among all. So in this way, you can prioritize the test. All right. So let us summarize what we have discussed today. We have discussed an approach for test case prioritization based on the requirements. This approach I have already told you consists of 3 steps. First, you prioritize the requirements using the square factors. Then you prioritize the modules. You have to map the prioritized requirements to their corresponding modules to get the priority modules. And finally, you have to prioritize the test cases of these priority modules for execution. So different equations we have told, different models, mathematical models. Using those, you can prioritize the requirements, the modules, and the test cases. Okay, this is what we have seen today. Again, we have taken it from chapter 2. Sorry, chapter 12 of Nurse 1. Thank you very much. So, any doubt, please? Let's see if any doubt. Very simple. Just you have to take and the similar ready-made questions or ready-made problems you can take and that type.